So, hello and welcome to lesson 16 in our study of optimization 2. So, in this video, we'll talk about assignment problems. Oh, So, assignment problems, okay. So, I'm Guido Canreno, a final year student of mathematics KNUST, and I'll be taking you through this video. So, let's take some introduction. So, the assignment model is a special form of a linear programming model that is similar to the transportation model. There are differences, however. In the assignment model, the supply at each source and the demand at each destination are limited to 1 unit. So the following example will demonstrate the assignment model. Okay, so I'm going to use an example to demonstrate it. So it says the Atlantic Coast Conference ACC has 4 basketball games on a particular night. The conference office wants to assign 4 teams of officials to the 4 games in a way that will minimize the total distance traveled by the officials. The supply is always 1 team of officials, and the demand is for only 1 team of officials at each game. The distances in miles for each team of officials to each game location are shown in the following table. So you can see that here. So if official A moves to Raleigh, the distance is 210 and what have you. So in the linear programming formulation of the assignment model, all the supply values for each source equal 1 and all the demand values at each destination equal 1. So this example is formulated as below, right? So we are going to minimize the cost involved. So the cost here, for instance, will be, if we let x be the decision variable, then it will be XAR, but the cost is 210. Then plus 90. So this will be XAE. Then plus this will be 180 XAD and what have you. So you are trying to minimize all of these. So that's what you can see here. And these are subject to demand and supply constraint, right? So this will be the demand constraint. So we are going to have, for instance, when you come here, we'll have x here. It will be x AR, x AA, x AD, XAC. So when you add all this, so XAR plus XAA plus XAD plus XAC equals 1. So when you add all of them, they will give you 1. Then we also do our demand constraint. So when you add all these, so here XAR, then XBR, then XCR, then XDR should be 1. So when you add everything here, you should get 1. Right? So we are going to have 8 constraints. So 1, 2, 3, 4, 5, 6, 7, 8. So the problem that we had there, this is the formulation of that model, right? But mostly when we are solving it, we use the Hungarian method, which is very simple. We don't solve this whole model using our simplest algorithm that we know. So let's take a summary. So an assignment model is a special form of transportation problem in which all supply and demand values equal 1. So the above assignment model is balanced, and it is balanced because it is balanced. So an unbalanced model exists when supply exceeds demand or demand exceeds supply. Okay, so for instance, if let's say um we introduce another game site, right? Let's say Georgia. You could see that now we are going to have another demand here, which is 1. So the demand will be 5, the supply will be what? 4. So we can have an unbalanced transportation model. Or if let's say we don't have Georgia here, but we have another official E here, right? You can see that the supply will also be 5 and the demand is 4. So that means we're also going to have an unbalanced assignment model. So that's when we have it. And just as in the case of the transportation models, where when we have an unbalanced model, we try to balance it before solving it. We also do the same thing here. Okay. So now that we have taken a general overview of what the assignment problem is, let's now look at some methods that we use to solve the assignment problem. So, assignment solution methods. So, there are several methods for solving the assignment model, but we shall use the Hungarian method for the above example and throughout all the examples we'll be doing in this video, right? So, we mostly have an opportunity cost table that is developed by performing row reductions and column reductions. Then assignments are made to locations with zeros in the opportunity cost table. So an optimal solution occurs when the number of independent unique assignments equal the number of rows or columns. So if the number of unique assignments is less than the number of rows or columns, a line test must be used. When supply exceeds demand, a dummy column is added to the assignment tableau. I've said that. Then when demand exceeds supply, dummy row is added to the assignment tableau. So the assignments are made to allocations with zeros in the opportunity cost table. And an optimal solution occurs when the number of independent unique assignments equal the number of rows or columns. So a prohibited assignment is given a relative cost of m so that it will never be selected. So let's look at the steps. So the steps of the assignment solution method are here, right, as follows. So we first perform row reductions by subtracting the minimum value in each row from all the row values. Then we perform column reductions by subtracting the minimum value in each column from all column values. So in the completed opportunity cost table, we cross out all zeros using the minimum number of horizontal or vertical lines. So if fewer than m lines are required, then we subtract the minimum uncrossed value from all other uncrossed values and add it to all cells where two lines intersect. So we leave all other values unchanged and repeat step 3. So if m lines are required, m unique assignments can be made, right? Okay. So don't worry at all if you didn't get the step. We are going to learn how to apply them. And for me, I believe that it is when you apply them that you begin to understand them, okay? So we are going to solve our problem, right? This problem here. Mhm. If you could recall. So you could see that with this problem, the table was given as what we can see here, right? And this is balanced, right? This is a balanced one. So, okay, so when we have this, the first thing that we do is that we do what we call row reduction. So with the row reduction, this is how we do it. So for instance, we come to the first row. What is the smallest element number here? 90. Then we'll subtract each of the elements here from 90. We'll subtract 90 from each of the elements here. So 210 minus 90. I think this is giving us 120. This will give us 0. This will give us 90. And this will give us 160 minus 90, I think 70. Right? Then we'll come here to and ask ourselves, this second row, what is the smallest element here? 70. So we subtract 70 from each of the elements here. Here, the smallest one is 105. We do the same thing. Here, the smallest element is 65. So here we 80 minus 65, 65 minus 65, and what have you. So that's how we do the row reduction. So doing the row reduction, we are going to get this. Alright, so you can complete it yourself and you realize that you will get this. So after doing the row reduction, then the next thing is that we do what we call column reduction. So that's the step. So you see the step says perform row reduction. After that, perform column reduction. So we have learned how we do this. We're now going to do the column reduction. So with the column reduction, you see this is the column. So this is the first column, second column, third and fourth. So when we come here, what is the smallest element here? 15. So as we did, so we will subtract 15 from each of the elements here. So 120 minus 15, 105, 15, think 55 and 0. When it comes here, the least is 0. So 0 from each of these elements will still give us 0, 0. When we come here, the least is 35. When you subtract 35 from each of the elements here, I think this is 55, 25, 0, and 15. And here too, we look for the smallest one and we subtract each of the elements from it, right? We subtract it from each of the elements. So when we do that, the column reduction, we are going to get this here. Okay. So when we get this, then you can see that we have to do what we call the line test. And that's what the line test is about. So it says, in a completed opportunity cost table, cross out all zeros using the minimum, that's the keyword here, the minimum number of horizontal or vertical lines. Okay. So now this is our completed opportunity cost table. So you can see we have some zeros inside. We want to cancel all of them, but using the minimum number of lines. So you can see that we can do it this way if we want to. So when we do this, you can see this zero is cancelled. Cancelled. Cancelled, right? And cancelled. So we do something like this. But the question we ask ourselves is that, is this the minimum number of lines we can use to cancel all the zeros? You can see that here we used what? 4 lines. And the answer is no. Like we can do something more than that. Okay, so let me try to, let's just do a different one. So you can see that mostly how I go about mine is that I always use the line to cancel. So to cancel, to get a minimum one, to cancel the row or column with a lot of zeros. So you can see here, this one has a lot of zeros. So using just one line, you've been able to cancel all these zeros. Then you can use this. Oh, oh, sorry. So we were here, right? Okay, so I can use this line to cancel the zero here, and to also cancel the rest of the zeros here. So you can see that we're able to use some few, right, like 3 lines instead of the 4. So we always look for the minimum one. So you have to be very careful. If not, you might think something is minimum whilst it's not. Okay, so since we have 3 lines here, it means there are 3 unique assignments, but we need 4. So that means that this solution is not optimal, right? So we have to continue with it. And let's go back to this one. It says if fewer than m lines are required, right? So you could see that fewer than m lines are required. So we subtract the minimum uncrossed value from all other uncrossed values and add it to all cells where 2 lines intersect, and we leave all other values unchanged, right? After that, repeat the step 3. So we come here. So you see, when you come here, when you look at this, the uncrossed values, which of them is the smallest? So you can see that the smallest is what? 15. So that means we are going to subtract this 15 from all the uncrossed values. So subtract 15 from this, which will give us 90. This will give us 0. From this, which will give us 40. From this, which will give us 10 itself, which will give us 0. And from here, which will give us 60. Then after that, where the 2 lines meet, you can see here the 2 lines meet. So we will add the 15 to it. So 0 plus 15 is what? 15. Then here to 0 plus 15 is what? 15, because this is the place where the 2 lines meet. Do you get it? Then we will leave the rest of the values unchanged. So that means we are going to get this. Do you get it? Then when we get this, we cross out the lines again to see the minimum number of lines we can have, right? So yeah, you can see we can cross this. When we cross this, we can also cross this, right? And also, so they're crossing, like I told you, mm, you would have to be very careful, otherwise you always not get the minimum one. You can also cross this, then you can also cross this to get all the zeros out. So you see, I use 5 lines here to do that, but the question is 5 the minimum? You can see it is no. We can perform something better, which will give us something more than less than the 5, right? So it's all about trying to do the drawing the line which will do the minimum one for you. Okay, so I can do this, right? Then I can also do this, and I can also do this, and I can also do this, and now I have 4 lines, and this is the minimum I can have. Or I can also do this, do it sideways, so you can see this, and I also have 4 lines. So that means the minimum number of lines here is 4, and that corresponds to the number of assignments we have to do. So that means that we've gotten an optimal solution. So that's how we do it. So it says, since at least 4 lines are required to cross out all the zeros, this indicates that 4 unique assignments can be made and that an optimal solution has been reached. So now let's just make the assignment from the table, from the above table. So remember that assignments can be made to cells containing zeros. And once an assignment is made to a row or column, no assignment can be made to that row or column, right? So that's how we can do the assignment. So you see, when it comes here, so take away let me take away the this one so that you can see how we do the assignment. So it's we can only do the assignments in the cells where we have the opportunity, like the opportunity to correct the cells where we have zero, right? So that means that official A can be assigned to either Atlanta or Clemson, right? So we can assign him to just one. So we can assign official A to Atlanta. When you do that, you can assign official B to what? Raleigh, official C to Dallas, and official D to what? Clemson. So that's the first assignment we can do. Then the second one, we can assign official A to Clemson instead. Then we assign official B to Atlanta. Then official C can still be at Dallas. Then official D will be assigned at what? Raleigh. So you can see in all of them, demand is 1 and supply is also what? 1. Alright, so that's how we can do the assignment. So that's what you have seen here. Right, and the distance from official A to Atlanta, the site is 90. That is as given in the question, right? So as given in the question, right? So when you do that, so Atlanta is 90 and the rest, and realize that the minimum transportation distance will be 450 miles. Okay, so remarks: multiple zeros solutions exist for the above problem since multiple zeros indicate multiple solutions. So you could see that here we could do 2 assignments, and that was because you could see that in our cells here we're having 2 zeros. That means we can have 2 multiple assignments, 2 zeros here We're also having two zeros here, so that's what they indicate. Okay, right. So let's take a second example to make sure you really understand what we are doing. Okay, so it says, given the following cost table for an assignment problem, determine the optimal solution and compute the total minimum cost. And it says, show an alternate solution if there are multiple optima, right? So this is the tableau, right? So the first thing that we do is to do row reduction. So we take the first row, the minimum element is 2. So 10 minus 2, 2 minus 2, 8 minus 2, 6 minus 2. We do it for all of the rows, okay? So after doing row reduction, this is what we get. Then after we do column reduction, so we take this column, the least element here is 2. So 8 minus 2, 4 minus 2, 5 minus 2, 2 minus 2. Then we do it for all of the columns. So after doing column reduction, this is what we get. After getting our column reduction, we draw lines, right? The minimum number of lines to cross out all the zeros. And you can see that the minimum number of lines that we can draw to cross all the zeros out is 2, as you can see here. All right. So, but we need what? Um, 4 of them, right? So it means that our solution is not optimal, right? Because there are only 2 unique assignments. So we go to the next step. So the next step, what we do is that with this table that we have here, where we have crossed the values, we look for the uncrossed one. The least of them is 2. Then we subtract each. So we subtract it from each of the uncrossed values. So 6 minus 2, 2 minus 2, 3 minus 2, 3 minus 2, and the rest. Then where the 2 lines intersect, right, we add the 2 to it. So here will be 0 plus 2, which will give us 2. Then the rest of the cross lines, we cross cells, we leave them like that, right? We leave them untouched. So that's going to give us this. And here too, we will have to draw minimum number of lines to cancel out all the zeros. And that gives us this, right? You can see that we had just 3 lines, but we need 4 of them. That means still the solution is not optimal, right? So we go to the next step. So the next step is the same thing. So the uncrossed value, which of them is the smallest one? So we take 1 from you, 1 from here. So 4 minus 1, 3. 1 minus 1, 0. 1 minus 1, 0, 0. 2 minus 1, 1. 4 minus 1, 3. Then where they intercept, we add the 1 to it. So here will be 0 plus 1, 2 plus 1, which will be 3. Then we leave the rest unchanged, right? And that gives us this. And we have to draw lines again to cancel out the 0. So you can see that here, line 1, line 2, line 3, line 4. The minimum number of lines to cancel out all the zeros are 4. That means that our optimal solution is reached here. So we can do the assignment in this cell. So since at least 4 lines are required to cross out all the zeros, this indicates that 4 unique assignments can be made and that an optimal solution has been reached. So now let us make the assignment from the above table. So remember that assignments can be made to cells containing zeros, and once an assignment is made to a row or column, no assignments can be made to that row or column. Right, so we can do 2 assignments, as you can see here. So we can assign person 1, or is it operator 1 to machine C. Then we can assign operator 2 to only machine A. Operator 3, since we have already done an assignment here, to come to C, and operator 4 will go to machine D. So that's the first one we did, right? And we can do a second one too like this, and all of them, the minimum cost to be $26, right? So yes, there are alternate solutions, and these are the alternate solutions. I hope you get it. All right, so thank you very much for following this video, and I hope you understood things. If you didn't understand, always play the videos again, and trust me, the understanding will come. Okay, so in our next video we will talk about maximization assignment problem. When you have an assignment problem and our objective is to maximize instead of minimizing. So thank you very much and see you in the next video.